Hey everyone, today we're going to be building a prompt compression website. It lets you reduce the size of the prompts that you give these LLM AI models so they can run faster, cheaper, and fit more into their context window. So stay tuned. Hey guys, Nick from the future here. Now in this project, we were trying to look at ways that we could reduce the prompt size, both because I'd found that it does reduce the cost and the speed because you pay for LLMs according to both the input token amount and the output token amount, but also note that this is only one part of the problem. Actually, the input tokens tend to be a little bit cheaper than the output tokens because the way that the transformer architecture works is that you compute the input tokens once, so the prompt that you're giving to the LM, but the output tokens, it's next word prediction, so it predicts one at a time, so the output tokens tend to be more expensive. So a lot of different types of optimizations. This is just one, and it's not the only one, but hopefully this video is helpful and interesting, and stay tuned on what's next. So for this, we're gonna be I'll start the project, and I'll be doing more of a quick cut in this one. It's not going to be a full 2, 4, 6 hour video. So we'll start here in the terminal, and we'll cd into my desktop. We'll go into the project's directory. Now that we've put the .n file in there, we now have Cursor ignoring the credentials file, which is good. And what we'll start doing is what we want to build here is a way that anybody can try to compress prompts. So in order for an LLM to go faster, you can obviously do a variety of things. You can make the transformer itself and architecture be faster, run it on kind of better hardware, faster hardware. And obviously we'll dive in maybe in another video, but you can be memory or flops bound. You can make the prompt smaller in terms of tokens. Or you can make, for example, the output tokens more concise so that less tokens are really needed. Because obviously you can look at metrics as tokens per second, but I like looking at more information per second, which obviously is really hard to measure. But the more concise the answer, the quicker it's going to be as well. So we're going to be focused on some of the inputs and exploring some of that. As part of that, I'm going to obviously put it here just in the chat window. So there we go. Quite a wordy first prompt, but let's see what it kind of comes up with. And in the background, I'll just I'll set up the Python environment as well. So Python. So there we go. We'll put this in app.py. And it might be on 501. So it's maybe removed too much here. How are you doing? And we'll say that is too many stop words. Do only the main ones that add no extra info / meaning. 3 sentences. And as you can see here, we'll have to do some tweaks, but there we go as in terms of a first version. I'm probably going to speed up and do a couple different techniques. I'll be looking at different prompt compression techniques. There's obviously ones that are classical to natural language processing, or NLP. It basically just means removing, for example, stop words. You can, for example, remove vowels from words, and so it ends up looking something like H, there, how are you doing? Like something like that, which actually LLMs can actually interpret quite well. But the thing is, because of how transformers work in terms of tokenization, if you use a tokenizer and already it kind of includes that vowel piece, it might not actually be less tokens, even though it's less characters overall. There's also techniques like making into snake case if characters is what you care about, like hi there, how are you doing? And so what that does is it reduces the amount of characters because you remove spaces, right? And there's going to be a lot of spaces. But again, according to the tokenizer, that might not reduce it. And so there's LLM-based ways that you can actually reduce prompts, where you summarize sentence by sentence into a more compact shape. And that's called selective context. And so we'll be looking at some of that as well. But I might fast forward and I'll see you on the other side and when we have a bit more of a complete solution. Hey guys, how's it going? This is Nick from the future. We've gone a little bit further into the prompt compression project, and as you can see here, now it takes a little bit more time to build, but we've created a prompt compression app. And so, as you know, it takes on the left-hand side your prompt. So here I've just asked like one of the common kind of chat LLMs for a prompt. And here I've put different things. You can remove fillers, remove vowels, and camel case. And what's quite interesting is, here I'll put it at 0.5, but I have different ways like removing fillers. And so here you see that it's reduced it by almost 20% by removing filler words. Like the, etc. So imagine your A season, so it removes, imagine your seasoned detective investigating mysterious disappearance, and that's reduce the tokens by up to 20%, which is really interesting. We also, if we do remove vowels, so it says instead of renowned, like RNWNUD, we see that actually it can actually increase the amount of tokens. Which is interesting. And that's just because of the tokenization. So even though we see characters has gone down, tokens has gone up. So it's actually not very good. If we do camel case, we also see that we remove all of the spaces. It actually increases the amount of tokens as well, and even though it reduces the characters. But if we apply selective context and remove filler words, we can see here, for example, with a ratio of 0.5, what it's doing is it's going into each sentence and summarizing it. Here you see it says, renowned scientist has vanished without trace from their highly secure laboratory. You'll need to analyze this. So it's really summarized it on a sentence by sentence. You can also do phrase or kind of token, but it's compressed it by kind of 0.5. And so here we see the added of remove fillers. If I don't remove fillers, it does 50%, so already removing fillers does some kind of level of maybe 5% or so. But I can also change the ratio of compression and the ratio of summarization of each sentence. So if I do 0.9, here you can see that it's summarized it a lot more, which is almost 86%, which is amazing. The only thing is that it would have probably impact the LLM accuracy quite a lot at this rate. So be careful with how much you compress. But hopefully this is a kind of interesting way using selective context. And here I've just put the link to the selective context paper as well. I believe it's using some of the GPT-2 kind of compression here. But yeah, hopefully you find that interesting and useful, maybe in many ways. But what I'm going to do next is deploy this. So after a lot of debugging, what we've done is the following. We've managed to, instead of using Heroku, so unfortunately the slug in Heroku has to be 500 megabytes maximum, or actually, sorry, 1 gigabyte. And so we weren't able to deploy some of the dependencies, including PyTorch, which ends up being super big and ends up being just above 1 gigabyte. So I've tried everything to try to make that work, but instead I've gone with the option of using Azure. And so we've created a URL here, and we're using Azure functions, which is their kind of serverless component, and just deployed this app serverlessly. So it's pretty much almost there. I'm just waiting for the custom domain to kick in, and now we're just as a last piece going to make this look a little bit sexier. So I'm going to just say here to make the UI background nicer and modern. But yeah, that should pretty much be it. Hey everyone, so there you have it, our prompt compression website. Hopefully this will help you somewhat in reducing the size of your prompts and making your LLMs go somewhat faster, be somewhat cheaper, and maybe fit more in towards a context window, Obviously, keep into account that some of these techniques that we've kind of played around with can obviously affect the accuracy of the LLM, so please test that out yourself and see if you really need it. We've seen, for example, some work less good, like removing vowels and the removing of spaces, just how tokenizers work. That might actually be more tokens rather than less, but we've seen this from some papers like the selective context one, that can actually help reduce tokens and increase the information density. So it summarizes, but it does have some loss in information there because you're summarizing it. Filler words also seem to not necessarily add to it, so we might like to speak to the LLM like in normal English, but potentially broken English for them is fine as long as it's the information that's needed is there. So please test this out for yourself. Obviously no promises, but hopefully it helps out a few people out there, and thanks for watching.